Hi, I'm Pete Burns, Technical Marketing Engineer with XIO Technologies. This video will go through a high-level explanation of CADP and our new feature, Media Affinity, now available on ICE 2.8 firmware and ICE Manager 4.04. We will also go into a common use case for Media Affinity, specifically pin-to-flash volumes to be used for VMware Horizon View replica disks. In cases like this, using Media Affinity for replica disks and then CADP for link clones, administrators have the option to tune the storage array to meet their needs. What isn't being managed with Media Affinity is being managed with CADP. Before going into the configuration and solution, let's quickly look at what happens with CADP and then compare it to a Media Affinity configuration. Legacy Hyper ICE and 7 Series ICE only use flash storage when CADP, Continuous Adaptive Data Placement Cost Algorithm, promotes and demotes sheets of data to and from the flash storage. The ICE volumes leverage both flash and HDD to provide the best possible performance for different types of workloads. The cost algorithm ensures that the hottest data blocks are continuously and dynamically up-tiered to the data pack's flash storage, where those blocks remain for as long as they are hot. Every 5 seconds, the CADP engine determines which new blocks need to be promoted into flash, and when the flash space is at full capacity, which flash resident blocks have cooled and can therefore be returned to HDD storage. CADP not only enables acceleration through data movement to flash, but also by providing an even access pattern on HDD, which in turn provides faster seek operations as there is less time spent on hotspots. So what is Media Affinity? It is the overall concept of utilizing ICE storage in a customizable manner. It provides the administrator with the ability to create volumes for specific purposes where all flash or all HDD solutions may be preferred by an organization. For example, all flash solutions are frequently leveraged for VMware Horizon View replica disks. Media Affinity only applies to ICE 7 series, Fiber Channel and ICE SCSI, and legacy ICE 2s with hyperdata packs installed. Media Affinity allows the customer to reserve a portion or all of the ICE flash storage for the creation and usage of permanent flash storage volumes. These permanent assigned storage volumes are referred to as pinned. Upon the creation of these pinned volumes, they will not use CADP. Media Affinity also supports pinning to HDD. When creating a volume on ICE containing flash storage, the customer now has 3 different choices: CADP, pin to flash, pin to HDD. VMware recommends high-performance data stores are used for VMware Horizon View replica disks. Placing the replica disks on flash storage ensures the high read I/O needed for VDI boots, refreshes, and recompose operations. Our internal tests recorded up to 20% improved performance with these administrative tasks. In this configuration, link clones in the desktop pool are directed to CADP managed volumes. As I noted in the previous slide, every 5 seconds the CADP engine determines which new blocks need to be promoted into flash, and when the flash space is at full capacity, which flash resident blocks have cooled and can therefore be returned to HDD storage. So when the link clone desktops need more resources, CADP will promote them to flash. When they need less, they are demoted. The flash space used for Media Affinity is never impacted by CADP. The replicas will always have reserved flash resources in the storage pool. This configuration demonstrates a scenario where managing an application with Media Affinity is an excellent use of resources that is supported by the vendor's best practices. It only takes 2 easy steps in ICE Manager to create a flash volume and VMware Datastore that replaces tasks typically done at a management console in a traditional storage array, and then followed by tasks in the VMware Virtual Center client to create the data store and present it to all of the hosts in the cluster. In setups like that, It is often done by two different teams in an organization. Ice Manager, however, is tightly integrated with the VMware ecosystem, and in the demo that follows, you'll see how easy it is to create a flash volume and data store. The first step is to reserve space on flash for Media Affinity. This is done in the Modify Pool wizard in Storage View. A quota is defined in this wizard that is the actual disk space reserved for flash volumes. The usable space is the quota in either a RAID 1 or RAID 5 configuration. The second step is in Server View, and you'll see how tightly integrated it is with the VMware ecosystem. And now I'm going to go forward with the demo. We're going to create a Flash Media Affinity volume and VMware VMFS data store from Ice Manager. As I noted in the previous slide, the entire process will be done with two wizards. You never have to go to the command line or the VMware Virtual Center client to execute the tasks. However, during this demo, I will open up the VMware Virtual Center client to show the tasks being executed by Ice Manager. In this configuration, we are managing three ICE 700 series hybrid storage arrays in a SAN group called Media Affinity. Our new volume will be built in one of the storage pools in one of the three storage arrays. That volume will be used to create the all-flash data store that will be presented to one of the VMware ESXi clusters being managed in Ice Manager. We're going to start from Storage View. Highlight the storage pool, right-click and select Modify Pool. The flash quota is that amount of flash that will be used for Affinity and then not managed by CADP. Each data pack has 1.4 terabytes of flash, and it is reflected in this screen as flash capacity. If a 300 gig quota is set, 1.1 terabytes will remain for CADP managed volumes. In this screen, the quota is 0. No flash quota has been set yet. When quota is set, the flash quota field will reflect that setting. When the volume is created from the flash quota, that amount will be shown in the flash used field. So we're going to set a quota of 300 gigs. And I'm just going to slide the tab over. And then click Modify. And it's done. I'm going to close out of here, and if I go back into the Modify Pool screen, I'll see the new quota reflected, and there's 300 gigs. The Modify Pool wizard was step 1. We reserved 300 gigabytes on flash for a Media Affinity volume. Now we will do step 2 with the Datastore wizard. Start from Server View in the VMware Ecosystem tab. Highlight the ESXi cluster that will use the flash data store, and then click on Datastore Operations. In this case, our cluster is xpod1 ch2 perf. In Datastore Operations, click on Create Datastore. This will launch the wizard. Click Next. In the Formatting Options screen, if you are running ESXi 5 or higher, choose VMFS 5. Click Next. In the Choose Properties for Datastore screen, name the data store. Ours will be ICE-VDI-replica data store. The data store size is the amount of usable space you want the data store to be. The actual usable space is the quota, in this case, 300 gigabytes, in a RAID 1 or RAID 5 configuration. For best possible performance, XIO recommends RAID 1. For a more economical approach, RAID 5 may be chosen. In a RAID 5 configuration, our 300 gigabyte reserved flash quota will yield 240 gigabytes of usable space. In the Select ICE field, by default, the selection option is set to automatic. All of the storage arrays in the SAN group are options in this field when we change the default from automatic to manual. When we click on the Browse tab, all of the storage arrays in the pools with their flash quotas are visible in the pop-up screen. In Storage Array ICE-B Pool 1 Flash, we see the quota reflects the reserved amount set in the Modified Pool Wizard. It is listed as 300 gigs. Because of the RAID level being set to 5, the usable space is 240 gigs. When it is set to 1, the usable space will be approximately 160. The RAID level, as noted in this pop-up screen, is set on the previous screen. I intend to use 100% of the usable space for this data store. Leave the data pack type to any and change the affinity to pin to flash. Multipath policy will remain as round robin. Then click Next. In the Host Initiator screen, the hosts in the cluster will be checked by default. This will result in the data store being presented and available to all of the hosts. If for any reason you want to present the data store to specific hosts in the cluster, simply uncheck hosts that should not see the data store. The LUN number listed in the screen is the next one available to use. You can choose to change it if you want to. And click Next. The final screen is the summary of the new configuration. The data store name, size, storage array, RAID configuration, and formatting. The host initiator connections identifies the target WWNs of each of the HBAs on the hosts. When I click Next, ICE Manager kicks off the process. In the VMware environment, ICE Manager starts rescanning the storage configuration of the hosts in the cluster. You can watch the process take place in the Recent Tasks windows of the VMware Virtual Center client. The new data store will be created, and another rescan will take place before it is available for use. When it is completed, click on OK, and you can review the configuration in ICE Manager and the Virtual Center client. In Server View, we can see the new data store is listed with a capacity of 239 gigs. In Storage View, I'm going to look at the properties of the new volume, and then I'm going to see that it's pinned to flash. In the Virtual Center, the new data store identification is the name we gave it in ICE Manager. The drive type is SSD, and the capacity is how we define the usable space in the wizard. We are ready to create the VMware Horizon View desktop pool with replica disks pinned to flash. In VMware Horizon View 6, I'm going to create an automated desktop pool. I'm going to make it a floating pool and use View Composer for link clones. And I'll give it a name. In this case, it's just going to be Demo Pool. As I continue to build the pool in the View Administrator, the configuration of the pool doesn't really change until we get to the storage optimization screen. In this screen, we have the option to select a separate data store for the replica and OS disks. Checking this option allows us to pin the replica disks to the flash data store we created using ICE Manager. I'm going to click Next and then go into the vCenter settings screen. Option 6 allows us to choose the link clone data stores. These are going to be the CADP managed volumes in the storage pool. I'm going to click Next, and then I'm going to go into Option 7 and select the data stores for the replica disks. My replica data store is shown has the drive type of SSD and available capacity of 239 gigs. And that's all there is to it. I can start the build of the desktop pool with replica disks pinned to flash. Thank you for taking time to watch the video, and feel free to reach out to me with your questions about your own VDI environment or future plans of building a successful VDI implementation.